Let's see the thyroid gland then. Thyroid gland. Thyroid, adrenal gland, pituitary gland. These three are very, very, very important. Okay, do remember that thyroid, pituitary, and adrenal. So now we are talking about pituitary gland. We are completed already. Then we are looking toward the thyroid gland. Thyroid is a butterfly-shaped gland that straddles on either sides of the upper part of the trachea below the larynx. Below the larynx. Okay, so this is the trachea. You can see here, this is the trachea. The diagram I took from the textbook. And this is the thyroid gland. Thyroid gland, you can see here. Then trachea, either upper part of the trachea, below the larynx, location of thyroid gland. Okay, the right and left lateral lobes lie on either side. Let me show you that lobes here. These two are the lobes of thyroid gland. The right and left lateral lobes lie on either side. Connecting the lobes, a mass of tissue called isthmus. This is isthmus. Okay, so that is isthmus. Okay, so let me show you. Let me show you here. This is the gland, the two lobes of thyroid gland, which are connected by that a mass of tissue. We say it as isthmus. So this is isthmus, and that with connecting the two lobes of thyroid gland. Okay. Then next, let's continue. The thyroid gland consists of microscopic spherical sacs called as thyroid follicle. That means if you take this particular, you can see small lobes are present there. Each thyroid gland is having many lobes. Okay, so the lobes you'll find here, thyroid follicle. These follicles or lobes contain that colloid lobes we already said. That's why the branches of lobes we can say, we can use the word lobules or you can use the word follicles. Okay, so these contain colloid composed of the glycoprotein thyroglobulin, just for information, thyroglobulin, which fill most of the thyroid gland. These lobes are going to contain the colloid and composed of the colloid, which is composed of the glycoprotein called thyroglobulin, which fill most of the thyroid gland. The wall of each follicle consists of two types of cells. Under the influence of TSH, the follicular cells synthesize hormone called thyroxine. That means we know the TSH is released from the pituitary gland will come and stimulate the thyroid gland for the secretion of a hormone called thyroxine. Thyroxine hormone released under the influence of TSH. And that is influenced by TSH RH of the hypothalamus that we discussed in the earlier classes. So this is the total story. Hypothalamic neuron secreted TSH RH will come and stimulate the anterior pituitary to release the TSH, and that TSH is going to stimulate the thyroid gland for the secretion of thyroxine hormone, which is also called T4 because it contains 4 atoms of iodine, and T3 which contains 3 atoms of iodine. Triiodothyronine, tetraiodothyronine. We need to know here the participants for the preparation of the thyroxine are two. One is iodine and other is an amino acid called tyrosine. One is iodine and another is amino acid tyrosine. So the combination of iodine and tyrosine can make T3 triiodothyronine or can make T4 tetraiodothyronine. The T3, about the T3, triiodothyronine, when it comes, it is more active and several times more potent than the T4. But actually it is secreted in small amounts. T3 is secreted in small amounts. The T4 is converted into T3 by removal of one iodine. That means T4 need to be converted towards that T3. T3 is very active, that you need to remember. Because the T4 and T3 have virtually identical effects on the target cell, they are usually considered that together under the designation of thyroid hormone or TH or thyroxine hormone. We generally generalize that thyroxine. Now you need to understand thyroxine means there are two types, T3 and T4, triiodothyronine and tetraiodothyronine. Okay, triiodothyronine and tetraiodothyronine. Then thyroid gland is the only endocrine gland that stores its secretory product in large quantity. Actually, there is no gland in endocrine system will store that automatically whatever the produced over that will go on. But this is the only gland which store and secretory product in large quantity. T3 and T4 are synthesized by attaching iodine to the amino acid tyrosine, which we call it now that by enzymatic action, and stored for some period of time and then secreted into the blood. The T3 and T4 in the loops, they get stored for a period of time and then secreted into the blood. Then let's come with the functions of the thyroid gland. The function of this vital gland are, there are so many functions actually. Thyroxine plays a vital role in the body. So then when we say, immediately will come in our mind, it maintains the basic metabolic rate. It is to regulate the basic metabolic rate. To regulate the metabolic rate, it is required. And how? That to regulate metabolism by stimulating the protein synthesis, participates in the protein synthesis, and it maintains normal body temperature. Our homeothermic body temperature is maintained by thyroxine hormone. That all will come under BMR, basic metabolic rate. All the activities of the body metabolic activities are going to be done by thyroxine, we can say. When it comes to the frog, that you may know that frog is having a larval form called tadpole larva. In the tadpole larva, to become the frog, the what is required? Thyroxine hormone is required. In case of frog, if we remove thyroid gland in the tadpole larva, never it become adult. That means in the tadpole larva, if you remove the thyroid gland, experimentally if you remove the thyroid gland, it won't become adult. It cannot become frog, adult frog. So that means the thyroxine is very important in the metamorphosis of larval form into the adult frog. Okay. So then that thyroxine hormone is regulating the development of mental abilities, mental faculties of the body. That's why you can see in this case hyposecretion, which leads to the mental disorders also. That we'll discuss about the disorders. To enhance some action of neurotransmitter like adrenaline and noradrenaline, their action, because we know that adrenaline and noradrenaline are the fight and flight hormone. That means at the time of fight, flight, fright, we need our metabolic activities need to be improvised. That's what we said, metabolic rate, it participates. So that means it also enhances the action of the adrenaline and noradrenaline, we can say, in relation with that. Simply, you need to remember finally that output here that thyroxine hormone helpful for the basic metabolic growth. And it also helpful for the growth of human being. As we know, the growth hormone of the pituitary gland is helpful for the growth, but thyroxine is also helpful for the growth. That we understand when we see that the disorders here. So then let's talk about the thyroid gland. We just already said now that each side that the lobes are present, two lobes, and lobes are connected by isthmus. And here in the thyroid gland, that as I said now, there are many lobules or follicles are present. These follicles are going to secrete the hormone called thyroxine, and about the thyroxine as T3 and T4 we discussed it now. Now I am going to introduce a special kind of cells which are present between the follicles. We say them as parafollicular cells. Parafollicular cells. Okay, so don't be confused here. The black one which I am saying, that is follicle, isn't it? So that follicular cells are going to secrete the hormone called thyroxine. Okay, the follicular cells secrete thyroxine. Then between the follicle, there are some special cells are present. We call that cells as parafollicular cell. These parafollicular cells are going to secrete a hormone called calcitonin. That means thyroid gland is also releasing the another hormone. What is that? Calcitonin. Let me differentiate that thyroxine released from the follicular cells of thyroid gland. Then calcitonin released from parafollicular cells of the thyroid gland. Okay, just to remember the two statements here. That follicular cells of the thyroid gland release thyroxine. Para, why? What is para? Para means aside. Aside of what? Follicle. So remember, anywhere we use this word, para means aside. We used it in first year, subkingdom parajuva, that That subkingdom is put aside because of phylum porifera. So anywhere we use this word, para means aside. Side of what? Follicle. Para follicular cells. That means a special cells present between the follicles going to secrete a hormone called calcitonin. Okay, so it is to control, simply we say now, it is to control the blood-bone calcium level at blood-bone calcium level, but we'll discuss this, role of calcitonin in the body along with parathormone. When I go to the parathyroid gland, there I'll discuss. Till the time you just remember one sentence I'm giving here, that though I explain a lot in parathyroid along with the parathormone, but you need to remember this particular function. Calcitonin lowers the calcium level in ECF. It has some relation, antagonistic relation with the parathyroid gland. What is antagonistic condition? That also we're going to learn in parathyroid gland. So simply till the time you remember this, the calcitonin that lowers the calcium level in ECF. Okay, that was given simply here. ECF extracellular fluid, whatever it may be. That that extracellular fluid means the fluid which is present outside the cell. That may be blood, or that may be lymph, or that may be body fluid, anything. Simply we can say it as ECF. Okay, so do remember that. And there I explained calcium metabolism, how it is controlled by calcitonin of thyroid gland and parathormone of the parathyroid gland. So till the time, let me focus on thyroid gland secretion, thyroxine only. That means I am going for the disorders related to the thyroxine hormone. That is a very important hormone in case of thyroid gland is thyroxine hormone. So that's why let me discuss about the thyroxine hormone and calcitonin along with the parathormone I am going to say. Okay, so then now let's see here. The thyroxine, hypothyroidism. What is hypo? Hypo means lower the secretion. The secretions will become lower. We say that means thyroxine is going to be reduced in the body. Hypothyroidism. What are the reasons for the hypothyroidism? Maybe the failure of the thyroid gland. Thyroid gland may be failed over, or secondary to hyposecretion of the TRH or TSH. We are talking about TSH from pituitary gland, thyrotropic stimulating hormone of the pituitary gland, or TSH-RH. Don't be confused with TRH. TSH-RH, which we said from the hypothalamus there is a hormone. TSH-RH should come, and that should stimulate the TSH of pituitary gland, and that should stimulate the thyroid gland for the secretion of thyroxine, isn't it? So, by keeping all that in mind, we are trying to find out the reason. In a person, the thyroxine hormone levels are decreased. Okay, so what may be happened over? Maybe failure of the thyroid gland, or the failure of the TSH which is released from the anterior pituitary to stimulate the thyroid gland for the secretion of thyroxine, or maybe the failure of TSH-RH which is releasing from the hypothalamus. These are all going to be the reasons. The secondary to hyposecretion of TRH, TSH-RH, you need to understand. TSH or both maybe, or all may be the problem. So that means the various reasons we can expect over. Okay. Then an inadequate dietary supply of iodine, that is different. That everything is good. Hypothalamus is good. It is releasing TSH-RH. Pituitary gland is good. That is releasing TSH. Thyroid gland is good. That is working much better. But if that person through the diet, if he is not taking iodine, that leads to what? That leads to the thyroxine secretion maybe get reduced over. So that hyposecretion can be expected. The symptoms include reduction overall metabolic activity, the poor tolerance of the cold. We said the body temperature maintained constant by thyroxine hormone by increasing the metabolic activities of the body. So that's why hyposecretion, the basic symptom is going to be intolerance to the cold. Okay. Now let's talk about the specific names. I have to go through that the specific names. Hypothyroidism, the secretion, lower secretion of the thyroxine hormone. In case of children, what happens? We need to see here. Hypothyroidism in children. The hypothyroidism in children leads to cretin. That we say cretinism. cretinism. It exhibits dwarfism. Dwarfism we already seen in case of hyposecretion of growth hormone, isn't it? Pituitary dwarfism, hyposecretion of the growth hormone. I said it over pituitary dwarfism. Okay. So why I'm using that again here also? That hyposecretion of the thyroxine leads to the dwarfism. Is both dwarfism are same, or do you find any difference? Yes. In case if the growth hormone levels are reduced in the children, that except we can expect only dwarfism in case of hyposecretion of the growth hormone. That means a dwarf person we can see growth is not happen, that we say dwarf. But in remaining aspects in all the abilities are going to be like a normal person in case of hyposecretion of the growth hormone. That means I am talking about pituitary dwarfism. Everything is going to be normal in the case of pituitary dwarfism. That person is not at all any psychological disabilities he will show. That only physical disability is present here. But in case of thyroxine cretinism, the dwarfism, that what happens here that also affect the brain. Brain fails to develop fully. That is additional thing here. The difference between the cretin or dwarf of hyposecretion of hypothyroidism and dwarf of hypo secretion of the growth hormone. Okay, that you need to remember. And it exhibits a dwarfism. Let's read here. Because the skeleton fails to grow and mature. Patients are severely mentally retarded. That's what we are talking about. As the brain fails to develop fully. Okay, other clinical features, we'll find some more features like dry skin, the thick tongue, prolonged neonatal jaundice, lethargy, respiratory problems, constipation. That simply we say that thyroxine is participating in the basic metabolic activities of the body, which is much necessary. So that's why any kind of lethargy, nothing but the psychological disorders we can say. So let's see the cretin here. Let me show you the cretin. Cretin will be seen like this. Okay, okay, we just went out. The cretin will be like this. So the height wise, I have shown one more diagram here. This we say cretinism or hypothyroidism. During early ages, the thyroxine hormone is reduced over, we say hypothyroidism. In case of children particularly, we are talking. Okay. Sometimes we'll get one more problem actually. Sometimes we get that at the time when the baby is growing in the mother uterus itself, the baby is growing in the uterus of the mother. That means during gestation period, if thyroxine hormone in mother, if thyroxine levels are low in mother, okay, that also affect the baby, and followed after the birth, you will find this kind of thyroid disorders in the baby. Okay, so that means it is going to be more dangerous. We call, specially, we have a special name for that. That congenital hypothyroidism, we can see. By birth, the baby face the problem of hyposecretion, because during the growth development process itself, the face the hyposecretion condition. So we say that kind of hypothyroidism as congenital hypothyroidism. By birth itself, the hypothyroidism can be expected over. So till the time we discussed about the hypothyroidism in children. Now let's talk about hypothyroidism in adult. That means after the age 18, 20, what happens? Hypothyroidism in adult. The characteristic symptoms are weakness, cold intolerance, as usual. That means we said the basic metabolic rate it is going to maintain. Mental and physical slowness, the person is little bit slow. That dry skin, typical faces, and hoarse voice, results of the total serum thyroxine and free thyroxine index tests usually confirm the diagnosis here. So that is some of the medical language it seems to be. Let me say in our general language that if we go to the person, doctor, sir, I have problem in, I'm feeling so I'm problem by saying these symptoms like the slow response to the activities, the physical slowness, dry skin, that if all these kind of symptoms, with the symptoms, if we go to the doctor will suggest you to go for this TSH, T3, T4. T3, T4 and TSH test. Okay, so they suggest T3, T4, TSH test. Okay, then let's talk about the hyperthyroidism. Hyperthyroidism. Okay, so what is hyperthyroidism? The Graves' disease or hyperthyroidism or exophthalmic goiter. We say exophthalmic goiter. That there is a small mistake I done here while preparing the PPT. Please excuse me. You see this. This is exophthalmic goiter. That's why earlier when I said I didn't say anything about this diagram. So exophthalmic goiter. This is a space problem. I adjusted that here. Exophthalmic, ophthalmic. That means eye. You see here the close-up diagram I made it actually. Thanks to the Google. So that this is also that one of the symptom exophthalmic goiter. Okay. So that exophthalmic goiter, particularly we are talking about. So it is an autoimmune disorder. Autoimmune disorder. Why it is said to be autoimmune disorder, we'll discuss. But let us read here. Let me complete here. In which the person produces antibodies that mimic the action of TSH, but are not regulated by normal negative feedback control. These patients have a peculiar edema behind. Now let us see the symptoms. Thereafter, I'll explain the mechanism. That these patients have a peculiar edema behind the eyes called exophthalmic, which causes the eyes to protrude. That's what I shown to you. That eyes are going to be protruded over. Exophthalmic goiter. Okay, that causes the eyes to protrude. This disorder, like mixed edema, also occur more often in females. Okay, that some experiment says like that. Always that we can't say. So now let me explain this. Let me explain this. That wait. I lost. So let me go for the disorders. Here it is. I think cretinism we are completed, and exophthalmic goiter. Okay, so I want this. I want the page with empty page that to explain the disease. Okay, so let me remove the click to add title. Okay, so I'm trying to explain this. First of all, let us see what I am trying to explain. Hyperthyroidism. Okay, hyperthyroidism. So how it happens in case of that exophthalmic goiter, hyperthyroidism. Why it is called autoimmune disorder? That I am trying to explain. Just let's focus here. Hyperthyroidism is what he said that exophthalmic goiter. So why? How? So that discussing about the Graves' disease, hyperthyroidism. So here that explain this autoimmune disorder, we need to understand actually about the mechanism of that hormones that we discussed this earlier, like TSH, RH released from the hypothalamus. Then after that, that stimulate the anterior pituitary for the secretion of TSH. Now let's imagine this is a cell of thyroid gland. A cell of thyroid gland which is able to produce the hormone called thyroxine. Okay, so this particular hormone, thyroxine, that thyroid gland is having, as I said to you, specific receptors will be seen over. Okay, specific receptor. Just I am giving a hypothetical diagram here to show the specific receptor. Now let us try to understand this particular phenomena. The TSH released from the pituitary will come along with the blade and that start the stimulation. Like this. That you can see here, the series of molecules are coming and stimulating fit here in this area. So imagine that the lock and key. This is a TSH receptor and this is the TSH. So both will fix over as long as these molecules are coming and dropping out, just going out. So that thyroxine is going to be secreted over. This is the mechanism. Imagine when the thyroxine levels are increased in the blood, that increased thyroxine levels will inform to the hypothalamus. That hypothalamus now secrete the hormone called TSH-IH. That stop the secretion of this TSH hormone. So that's why what happens, there is no TSH will come here, and no TSH, that means thyroxine hormone is going to be decreased. That means optimum level will be maintained. This is the general mechanism will happen. And the very important thing you need to understand here, it's not like a just switch on the fan and the fan will move on continuously. That way, that any hormone mechanism we can't say like this. It is just like calling bell mechanism. As long as you press that much time that they are on. Means here, if you remove your hand from calling bell, that the sound will go off, isn't it? But that light or fan switches that are do you hold that? Are you doing that? Holding that, as long as you hold, the fan will move. It's a difficult thing, isn't it? But our hormonal activity is calling bell mechanism. As long as TSH will come and stimulate this particular, then that secretion of the thyroxine will go on. Imagine, oh, after a period of time, thyroxine level seems to be decreased in the blood, that decrease in the body. So what happens? That information will go to the hypothalamus. They secrete TSH-RH, releasing hormone. Then TSH started here, and then they stimulate that the thyroxine the cells of the thyroid gland for the secretion of thyroxine hormone. This is a story which is happening in the body. Very interesting, isn't it? That means all these magics are going to happen itself in our body. Okay, so what is the autoimmune disorder we say? Imagine if in our body such these kind of antibodies are produced. That means not for these actually, that some other antibodies, whatever we produced here, that immune system, if this matches, it's just like here, your key matching with your neighbor's lock. Okay, so that that means okay. Let me here. Only I erase this. That TSH is not coming. TSH is not coming because thyroxine levels are increased. Okay, so then TSH won't come. That slowly thyroxine levels will be managed. But some I'm talking about our immune system. Our immune system produced antibodies not for this actually. That sometimes they come and fit here. Sometimes they come and fit. So what? That means simply you need to understand somebody plastered the calling bell switch, not pressing. Just they press and they plaster. They applied plaster on this. Now the bell is ringing continuously. Means thyroxine is coming continuously. Cell is producing thyroxine. What happens? Thyroxine levels increases. That information goes to the hypothalamus. They start releasing IH, but nothing matters here because this is not due to TSH. This is due to our immune system. This is due to our immune system unknowingly binds with the TSH receptor. So can't we say this as autoimmune disorder then? Why it is called autoimmune disorder? This is very famous disease actually. That Graves and Cushing syndrome. Cushing will come in coming days, adrenal gland. The Graves disease is an autoimmune disorder. Okay. So how it is an autoimmune disorder, I explain now to you. Okay, so did you get my point here? Instead of TSH, somebody from immune system is doing the stimulation of TSH receptor. This is the TSH receptor. Somebody instead of the TSH is locked with the TSH receptor, then the flooded thyroxine you can see here. That what do you say? Hyperthyroidism or Graves disease. That it is called autoimmune disorder. Okay, I hope you understand. Now let's try to read these lines. It is an autoimmune disorder in which the person produces antibodies that mimic the action of TSH. That means look like TSH, but they are not regulated by negative feedback control. What is negative feedback control? That what we said now. What we said here, that in case that when TSH levels are increased, that automatically the information goes to the hypothalamus, isn't it? So, but that won't happen because now it is not by the feedback. That is done by the mimicking antibodies of the immune system. These patients have a peculiar edema. That means excess secretion of the thyroid gland leads to the swelling of tissues. So particularly in the eyes, that's why we say exophthalmic, which causes the eyes to be protruded over. This disorder like mixed edema also occurs more often in females that we just started about earlier. So that's it. Okay, so talking about exophthalmic goiter. Okay, that Graves disease or exophthalmic goiter, we discussed about this. Then, okay, so let's talk about, let's give the final conclusion to the thyroid gland and with its disorders. Okay, let me say thyroid gland. By classification, we can say it has two. Okay, one is hyperthyroidism that we said now that has a significance as an autoimmune disorder, Graves disease or exophthalmic goiter that we need to remember, and the name of scientist Graves, Graves disease or exophthalmic goiter. Okay, so this is the Graves. So let me erase this. Okay, next. Next, we need to focus on the remaining. That more confusion is here. Hypothyroidism. Hypothyroidism. So, what are there in children first? In children, simply we say cretinism. If at all problem is running from the mother uterus, that we say congenital hypothyroidism, nothing but cretinism again. Congenital hypothyroidism. Congenital hypothyroidism, which leads to the cretinism. Okay. After birth, due to some nutritional deficiency, that anything happened, hypothyroidism occurs, we say directly that baby growth is not happening. So before birth itself, the problem is get started over. The congenital hypothyroidism also leads to the cretinism. Okay. Next, what is the another one here? Another one that is simple goiter. In case of simple goiter, nutritional deficiency or deficiency of iodine, that tyrosine is available, but iodine is not available. So slowly follicular cells will start increase in size. That maximum size increase, the neck region you can see, thyroid gland, maximum increase in the size, we say simple goiter. Okay, so that means in that case there is no thyroxine at all because iodine deficiency slowly reducing the production of thyroxine. One fine day you don't find thyroxine in that person, that we say simple goiter disease. Okay, simple goiter due to the deficiency of iodine we are talking. Means synthesis is not at all happened. Synthesis of thyroxine is not happened. Okay, so that hyposecretion in children, cretinism. Hyposecretion during the embryonic development, we say congenital hypothyroidism, which leads to the cretinism. That is the next thing. And for any person, simple goiter can be affected. For any person, those who don't have, that who were not taking iodine through the diet, which we can say that will be affected with simple goiter disease. Okay. Next, the hyposecretion in adult. This is the last one here. Hyposecretion. I am making space myself. Hyposecretion in adult. In adult, I am making here, which leads to mixed edema. Person is going to be more sluggish and accumulation of the water and swelling of eyes, we can see particularly puffiness, inactiveness, all the conditions you can see there. Okay, so this is a complete picture of the thyroid gland. That is a complete picture of thyroid gland. Okay, so that's it about thyroid gland.